Hey, what's up, guys? Welcome to day 2. We're going to continue exactly where we left off with independent and dependent events. Today, we actually are going to be calculating the probability, not just talking about whether or not it's independent or dependent, but we're actually going to figure out what is the likelihood that two events might occur. All right, and so I'm going to start by talking about independence. I'm going to end by talking about dependent events, and then I'm going to give you opportunity for you to do some practice as well. So let's get into it. Independent events. And so independent events occur when one event does not affect the likelihood that the other event will occur. And so some examples that we saw last time was spinning a spinner, rolling a dice, flipping a coin, drawing a card, and then replacing it. Again, replacing it is key here, and then drawing another card. So in all of these cases, the first event, what you get the first time, does not affect what you will get the second time. So spinning a spinner, what you do the first time does not affect what you get the second time. Same thing with a coin, a dice, and then when you get something out, say you take a card out and replace it, those all do not affect the second event, all right? Now let's talk about how to actually calculate them, okay? And so to calculate it, we're going to use this formula, which is, okay, the probability of, we're going to say event A and B, okay? To find the probability that both of these will occur, we first got to find the probability of A, then we have to multiply it times the probability of B, okay? And so I'm going to show you how to do this here in just a moment, and you'll have some opportunity to practice, all right? So we have this spinner, okay? And we're going to be flipping a coin. So we have this spinner and we're flipping a coin. And so our question says, what is the probability of spinning a red and flipping tails? Okay, so in order to find the probability of both of those events happening, those two independent events, we first have to find the probability of spinning a red. Then we got to find the probability of flipping tails. Then we got to multiply them together. So let's do that. So the probability of spinning red on this spinner. Well, I got one red and I got 1, 2, 3, 4, 5, 6 total. So the probability of spinning a red is 1 out of 6. Okay. Now I got to find the probability of flipping a tails. Well, tails, a coin has two sides, heads and tails. So the probability of getting tails, sorry, that should say just the probability of finding B. Okay, that is 1/2, right? Now to multiply the probability of A, getting event A is 1/6 times the probability of event B, okay? So then I'm gonna do 1/6 times 1/2, okay? I could just enter that into decimals if you are unsure how to multiply fractions, but really, the reminder to multiply fractions, you just multiply straight across. So 1 times 1, 1, 6 times 2 is 12. So the probability of these two events occurring is 1/12. Simple enough. Okay, now I want you to take a moment, I want you to pause, and then I want you to try to do these following examples. All right, so in this first one, the probability of us spinning blue, okay, and getting heads, okay. So first I got to figure out what's the probability of spinning blue, okay. Probability of spinning blue on the previous spinner was 1 out of 6, and then what's the probability of spinning heads? 1/2. And so then I multiply those two and I'm gonna get 1/12 again. Right. Let's look at the next one. What is the probability of rolling a dice and getting an even number, then rolling a dice and getting an odd number? Okay, so what's the probability of getting an even number and an odd number when rolling a dice. Okay, so first I got to find the probability of finding an even number. Okay, on a dice is 1 through 6. 2, 4, 6 is even, so the probability of getting an even number is 3 out of 6. Okay, because again I have 6 sides. 2, 4, 6. Again, just to show you this, again, these are my numbers that are on the dice, right? And all of these are my even ones, right? So that's 3. That's how I got 3 out of 6. Okay. Now, what's the probability of getting an odd number? Well, 1, 3, and 5. So that's also 3 out of 6. And when I find the probability of both of those two, I have to multiply them. So probability of both of these, 3 times 3 is going to give me 9. 6 times 6 is going to give me 36. Okay. And now in this case, whenever you have probability, you are going to want to find your answer in lowest terms or simplified form. So if you can simplify it, make sure that you do. In this case, 9 goes into both of these, and so I can simplify this and I get 1/4. All right. So 1/4 is the probability that I'm going to roll an odd number and then, an even number, then an odd number. All right. Now let's look at the last one. You have 10 cards, 0 through 9. What is the probability of drawing a 1, replacing the card, and then drawing an odd number? Okay, so first, again, what's the probability of getting a 1 and then an odd number? Okay, so I got to find the probability of getting a 1. All right, I got 10 cards and only one of them is a 1. So that is 1 out of 10. And then what is the probability that I'm going to draw an odd number? Well, again, I'm just showing you this just for the purposes of making this real plain. Okay, these are all my cards, 0 through 9. Okay, how many odd numbers do I have? Well, I got 1, 3, 5, 7, and 9. So how many odd numbers is that? 1, 3, that's 1, 2, 3, 4, 5. Okay, so I have 5 odd numbers out of 10. Okay, and then I am going to multiply these two. Okay, so 1/10 times 5/10 is going to give me 5 over 100, which, again, if you will simplify that, you will end up getting, divide by 5s, 1 over 20 is the probability of those two events occurring. All right, so this is how to find the probability of two independent events. Okay, now we're going to look at dependent events. So dependent events occur if one event affects the likelihood that the other event will occur. Okay, and so in this case, imagine picking out a piece of candy and eating it. Imagine picking out cards and not replacing them. Okay, so whenever I take one out and I don't put it back in, now the total that I have is less, so that's going to change the probability of getting the second one, and we're going to see that here in just a moment. The probability of it snowing and then school being canceled. Okay, if the probability of it snows and then school canceled, those are related. If it snows, it's going to affect whether or not school is canceled. And then calling on students to participate in an activity, right? If I get one student to participate, now when I go to call another student, that student is no longer there, so I have a fewer number of students to call on, okay? So let's look at how to solve dependent events. So when you solve dependent events, you are doing the probability of A and B, but it is B after A. So you're going to find the probability of first event, Then you're finding the probability of the B event, but it's after you have found the probability of A, okay? And so I'll show you what that means here in just a minute, okay? So imagine you have this situation. The PE teachers are calling on students to play a game. If there are 20 girls and 15 boys, what is the probability that 2 girls will be called? Okay, so I got 20 girls, I got 15 boys. That means I got 35 students total. Okay, and so I am gonna need the total to figure out the probability. So first I gotta find the probability of picking a girl. Okay, probability of picking a girl, there are 20 girls, as we said, there's 20 girls. And how many total students are there? Well, there's 35. So it's 20 over 35. Then what is the probability of picking a second girl? Okay, now once I have picked one of the girls, I no longer have 20 girls left. Now I have 19. And so this is the key here. Okay, so now I have 19 girls. And then I also, no longer do I have 35 students, but now I have 34 because one of the girls were just removed from my total. And so now I'm going to take these two probabilities and I'm going to multiply them together. So 20 times 35 times 19 over 34. And so I want you to put that into decimals and see what you get. All right. And so what you do when you get that is your probability of those two events occurring. Okay? So now, on this slide, there are 2 examples for you to do on your own, okay? So I want you to attempt to do these and then check it and see. I'm not gonna solve these, I'm just gonna end up setting them up. So you are gonna need to make sure you actually multiply them to calculate the probability at the end. All right, so I have a bag of 10 red marbles, 3 green marbles, 7 yellow marbles, and 5 blue. What's the probability of drawing a red marble and a blue marble? Okay, without replacing it. So the fact that I do not put it back in is going to change the total, okay? So what's the probability of getting a red marble, okay? Well, the probability of getting a red marble is 10 out of, and I gotta add up the total. So I got 10, 3 and 7 is 10, 5, that's 25 total marbles. Okay, so that's the probability of getting a red one. So I have this red. Now, what's the probability of getting a blue? Well, I have 5 blue marbles, okay? And now, because I pulled it out and I did not put it back in, now I only have 24 total marbles. So that number is gonna be decreased by 1. And so then, when I multiply these, multiply across, that is going to give me the number of marbles I have. I'm sorry, not the number of marbles, I'm sorry. The probability of getting a red one, then a blue one. Okay, so make sure you put this in to the calculator if you need to, and then multiply these two fractions, okay? I'm gonna know if you didn't actually hear that and do that by looking at your notes, and so you're gonna get something taken off if you do not have the answer to that, okay? All right, let's look at the last one. Mr. B has 8 girls in a small group and 5 boys. What is the probability that he calls on a girl, then he calls on a boy, if he's not calling on people more than once? Again, the fact that he's not calling on them more than once means he's not going to call on the same person, so that's going to affect the probability, okay, or the total. So the probability of getting of calling a girl and then a boy, okay? So what is the probability of calling a girl, okay? Well, it is 8 out of how many total students? 8 and 5, that is 13. So he has 13 total students, okay? So the probability of getting a girl is 8 over 13. And then once he has called on a girl, what is his probability the second time calling on a boy? Okay, so there are 5 boys, but how many students are there total? Now, after he's called on one already, well, hopefully you're catching on that there is one less. So now he has 12 boys. And so now I'm going to multiply this, and that will give me the probability of him calling a girl, then calling a boy. All right. And so hopefully you have seen that, again, the difference between independent and dependent events is that you're seeing that the total is changing in dependent events, right? In independent events, because those are not affected by the first one, those, the number of outcomes are not changing, okay? But in dependent events, it does, because dependent is affected by the first event, all right? And so I'm gonna have I'm gonna have an assignment for you to do to get additional practice. Remember, if you need to go back and watch something, or if you got a question, raise your hand. But hopefully this has helped you learn how to calculate and determine the probability of independent and dependent events.